Hello and welcome to this second video. In the previous video, we discussed about the indices. Introduced indices and we explained why we write a dot a dot a dot a to 4 times as a to the fourth power. In this video, we will not be discussing or explaining any of this, but rather we are going to concentrate on how to work with this exponent we have put in place in mathematics. So this is a notation and we're going to work on how we're going to handle this notation. For one, let's say we have to multiply a to the fourth power and we're going to multiply it by a to the fifth power. What we can do is to just expand both of them directly. So this will go as follows. This is a dot a dot a dot a dot a. So no, this is okay, so this is 4 times, so I wrote it 5 times there. And then this is dot, stay yet. Then the a to the fifth power, this a dot a dot a dot a 5 times. So this one is 4 times, this one is 5 times. Now how many we have obtained a product of a throughout, and since it is just a, how many times does that appear? 1, 2, 3, 4, 5 plus 4. This is 4, this is 5, this is 9. So the answer is then a to the power of 9. A to the power of 9. It's looking like 9 to the power of 9. So, but you get the gist. A to the power of 9. So you see that we could have just come here and added a to the power of 4 plus 5 to give us a to the power of 9. And if we do this example for another case, let's say we have a to the third power and we want to multiply by a to the second power. As usual, this is a dot a dot a, and then this is now a dot a. So of course here appears 3 times and here appears 2 times. So it seems that this is equal to a to the fifth power. But then it seems that we could have just come here and say this is a to the 3 power plus the second power, which is a to the fifth power. In general, if we have a raised to the power of m multiplying a to the power of n, is it true that this whole expression is equal to a to the power of m plus n? And that is the question, where m and n are integers. Where like m and n may be 5, n may be 14. And then although this method we've been using is good, whereby we can write one of them a to the 4 power as this and then a to the 5 power as this. But the reason we like general formulas in mathematics is because what if we now have m is 100? Are we going to write down a 100 times and then write down a? And if n is 1000, we'll now go and write down a 1000 times? No. We like to find a neat formula that allow us to find this thing for all m and n, regardless of whether m is large or not. And this formula is not too hard to drive. This is how we go about it. A to the m is gotten by fixing a and multiplying it by itself, multiplying a, and the number of times I'm multiplying a here is equal to the power of which we have raised a, and this is m. So a is multiplying itself here m times. So come here and write m times. M times. On the other hand, we're multiplying it by a as well, and it's just like before. This would be a multiplied by itself, and we're going to continue this forward, and this will repeat for n times because we have raised a to the power of n. Now when we consider this, that here we have all of them being equal to a, the end product, the result should be in this form: a but then the power here, the power should be what we count, how many a's that appear here. So let's count the first a. Here we are going to a has been multiplied by itself here m times, so of course we're going to count m times of a, and then here a has been multiplied by itself n times, so it seems that we are going to count a m plus n times, because here we count a m times plus how many times a appear n times, so it seems that this will be a to the m plus n, and this is the first law of indices we are proving, that a to the m multiplied by a to the n is equals to a to the m plus n times. This is a general fact in the theory of indices. Thank you for your watching my channel and video, and if you like my content, please subscribe to my channel. As usual, you can check through my previous video for what I offer. Thank you for your time. Have a nice day.